Good day. We discuss the past year 2021 question 19, which is about the refraction. A sharp image of a distant object is found on a sheet of paper placed near to a clear glass bowl of diameter 15 cm and refractive index 1.5. Determine the distance of the image from the side of the bowl that faces the object. So this is about a clear glass bowl that I have discussed a similar case in my video. So we will likely go through here. So there are two refraction you can take note. Okay, when the object travels through the glasses, this is where the first refraction takes place. Okay, it's from the less dense medium travel into the denser medium. So here, based on the calculation before that we have discussed, it will form a real image that will become the virtual object for the second refraction. And then we shall apply the formula again to obtain the second image. So let's try to solve this question. So I prepared another diagram that I've changed some of the values to become to the information given in the questions. So the word distant object means that the object comes from the infinity. Okay, that's the first thing you can take note. Okay, so the refractive index of A is still 1 and the medium is B equal to 1.5. So diameter given 15 centimeter would be the diameter of the ball, okay, the glass bowl, and radius will be equal to 7.5 centimeter. So let's explore the first refraction first. So I guess the calculation should be not too complex for you, that the object distance is infinity. We are going to get the image distance and the radius is equal to 7.5. So the first image here will be equal to positive 22.5, means that it is a real image and it will become a virtual object for the second refraction. So by looking at the diagram here, the first image distance V1 should be from here, okay, until this point, okay. So this is where the first image located. And then when we talk about the second refraction, we need to revise again the object distance, okay, which we get it from the first image distance. So the first object distance will be equal to negative of V1 minus 2R. So the negative here is because that the first image would become the virtual object for the second refraction. So here the object distance will equal to negative 22.5 minus the diameter of the ball, 15 centimeter. So plus 1 over V2 equal to here. Okay, so the things is still similar as the previous one, except the object distance should be revised based on the first image distance. So do the calculation and you should be able to obtain the image distance is 3.75 centimeter. So now the question asks for the distance of the image from the side of the ball that faces the object, which means from here until the image distance. So V2 plus the diameter of the ball, 15 centimeter, the final answer should be equal to 18.75 centimeter for this case. We move on to the next question. If the clear glass ball in A is reshaped into a biconvex thin lens with radii of curvature R1 and R2, derive a formula to show the relationship between the distance of the object U, distance of the image, and the focal length. So the derivation has been discussed in the syllabus, and I'm sure you know how to do it. So there's one very important assumption to be made when you do the derivations. By the word thin lens means that the thickness can be ignored, that the object distance is approximate as U, and the image distance shall approximate as V. So the key things that we've discussed in the previous solution is about the first image distance and the second object distance. So since the thickness can be ignored, so the magnitude of the distance is the same, except that the first one, okay, the first image distance is real, so it is a positive values, and the first object distance is a virtual object, so it is a negative value. So this is the important assumption when you do the derivations, and you should be able to solve the questions that the answer is 1 over u plus 1 over v equal to 1 over f as the thin lens formula. We move on to the last question. A biconvex thin lens has equal radius of curvature 15 centimeter. Determine the distance of the image when an object is placed 6 centimeter in front of the lens. So this is about thin lens, and we shall use the formula 1 over u plus 1 over v equal to 1 over f. But you're only given with the radius and we need the focal length. So here comes the formula of lens macro, that 1 over f equals to n over 2 over n1 minus 1 multiplied with r1 plus 1 over r2. So just put in a value, the focal length here should be equal to 15 centimeter, and apply the thin lens formula, you should be able to obtain the image distance is 20 centimeter. So next is to explain the characteristic of the image form. So quite simple, real and inverted. And based on the distance 60 centimeter compared to 20 centimeter, we can deduce that the image is diminished. So that's all for this question. Thank you.